Okay, in this next question here, find the equation of the tangent to the curve ln 3x squared minus 1 over x plus 2 at the point where x is equal to 1. Give your answers in the form of y equals to mx plus c. Now, in this time, they're going to tell you to give your answers corrected to 3 decimal places. Okay, so once again, let's imagine this curve here. Again, we don't know how the curve looks like. And then tangent to x equals to 1. Draw a line here. This is when x equals to 1. To find the gradient, it is always to find DYDX and substitute x equals to 1 inside, right? Now, DYDX, again, this question is a quotient rule. Differentiating ln, differentiate top first, you would have gotten 6x over 3x squared minus 1. Copy bottom, x plus 2. Minus differentiating bottom 1, copy top, ln 3x squared minus 1 over the bottom square. Okay, x plus 2 squared. Now, this is your dy dx. When x equals to 1, substitute 1 into here. 6 times 1 is 6. 3 minus 1 is 2. Times 1 plus 2 is 3. Minus ln of 3 minus 1, which is 2, over 1 plus 2 squared is 9. Okay, dy dx is equals to this. Then, now, before we type it into the calculator, I would like to use exact values as much as possible. This is just 319 minus ln 2 over 9. 9 minus ln 2 over 9. The reason is because this is far from the final answer, right? If I start simplifying now, my answer in the final answer, the decimal might be off by a little. So try to use exact values before the final answer. 9 minus ln 2 over 9. This is the gradient. 9 minus ln 2 over 9. Okay? Then when x equals to 1, substitute into here, y is also equals to ln 3 minus 1. That's 2 over 1 plus 2, which is 3. So y coordinate is ln 2 over 3. Now, from here, only we finally start substituting all the values in. Y equals to mx plus c, right? Ln 2 over 3 is equals to m 9 minus ln 2 over 9, x, which is 1, plus c. Then from here, only you start typing it into your calculator, you will get that c is equals to 0.692, 3 decimal places. Then lastly, substituting everything into your equation, y is equals to, now we can change this gradient into its decimal form as requested by the question. 9 minus ln 2 over 9, type it into the calculator, you get 0.923 x plus 0.692. This is your y mx plus c. Okay, this is the equation. Okay. All right, last question for this video. These kind of questions, everything is sketched up for you already, so it's slightly easier. But it is a 10-mark question, means to say that there's a lot that you need to write. The diagram shows the line of y equals to 1 minus 4x, meeting the curve of y equals to 4x squared minus 6x minus 5 at points A and B. The tangent to the curve B meets the horizontal line through A at point C. find the x coordinate of C, giving an answer correct to 2 decimal places. Okay, first thing that we're going to need to do is to find the coordinates of A and B, mainly to find B so that we know what the x coordinate here is. And once we have the x coordinate, we can substitute into the DYDX to find the gradient for this line here. Okay, so to find A and B, what you have to do is you're going to need to let the linear equation equals to the quadratic equation over here. 4x squared minus 6x minus 5 is equals to 1 minus 4x. Okay, bring everything over to form a quadratic equation. 4x squared minus 6x plus 4x, so that's minus 2x, minus 5 minus 1, so that's minus 6, equals to 0. Factorize the quadratic equation here, you would have gotten 2x and x, sorry, 2x and 2x, then minus 3 and plus 2 on this side. Therefore, x is equals to 3 over 2 and x is equals to negative 1. Using the graph that you can see here, you can use logic and explain that this is negative 1 coordinate something, and this is x coordinate of 3 over 2, y coordinate something else, right? Now that you have the x coordinates of A and B, you can actually find the y coordinates because you need to find the equation of this line as well. So when x equals to negative 1, then y, you substitute into this equation here, is equals to 1 minus 4 negative 1. This is equals to 5. Okay, therefore the coordinates here is negative 1, 5. Then similarly, when x equals to 3 over 2, y is equals to 1 minus 4 3 over 2. This will give me negative 5. 2, 3, yep, y negative 5. So this coordinate here is negative 5. Okay, now that I have the AB coordinates already, next thing I'm going to need to do is I'm going to need to find the gradient of this BC line here. To find the gradient, since they say that B and C are actually tangents, right? Then what we're going to do is we're going to differentiate the quadratic equation. Differentiate the quadratic equation, you would have dy dx is equals to differentiate this quadratic equation here, you would have 8x minus 6. And from the differentiation, when x equals to 3 over 2, then dy dx is equals to 8 times 3 over 2 minus 6. This is equals to 6. Yeah, 4, 3 minus 6. Yeah, 12, 6. So when x is equals to 3 over 2, dy dx is equals to 6. Meaning to say this coordinates, this straight line here has a gradient of 6. Now, next thing we're going to need is, we're going to need to form the equation of BC, having everything that we have here already. Negative 5 is equals to 6, 3 over 2 plus C. In this case here, C is equals to negative 5, 3, 9, minus 9. So this is negative 14. The equation of BC is actually equals to 6x minus 14. Now, the final part of the question is find the x coordinate of C, giving answers correct to 2 decimal place. To find the x coordinate of C here, since I already have the equation, which is 6x minus 14, and I know that this has a y coordinate of 5, all I have to do is substitute when y equals to 5, substitute when y equals to 5, is equal to 6x minus 14. Then bring the 14 over, 19 equals to 6x. And lastly, x is equals to 19 over 6, which if given to two decimal places, this is 3.17. Right? And that's it for this question. All right, see you in the next video.